Waste segregation has become one of the most pressing issues of our time, and innovative solutions are needed now more than ever. What if we could blend the precision of robotics with the power of AI to create a system that not only automates waste segregation but also bridges the gap between virtual simulations and real-world applications? In this documentary, we'll take you behind the scenes of a groundbreaking project, the development of a 6-degree of freedom robotic arm designed for waste segregation, all simulated within the immersive environment of Unreal Engine 5.
The journey began with the idea of creating a robotic arm that could mimic human movements with high precision. To achieve this, we focused on developing a 6-degree of freedom system, allowing the arm to move in any direction, rotate and grasp objects as effectively as a human hand. But building this complex system wasn't just about mechanics. It was about crafting a seamless interaction between a physical hardware and a AI-driven software. Unreal Engine provided the perfect platform to simulate real-world scenarios in a controlled virtual environment, where every movement, every grasp, and every decision made by the robotic arm could be fine-tuned to perfection.
What sets this project apart is the dual focus on high-fidelity simulation and real-world application. By leveraging Unreal Engine's powerful physics engine, we are able to simulate the dynamics of waste segregation with remarkable accuracy. The AI model trained within this environment is designed to adapt to both visual and physical realities. This means that the same algorithm that powered the robotic arm in simulation can be deployed in a real-world setting, making the transition from virtual to real seamless and efficient. The deep neural networks developed for this project were trained to recognize and sort different types of waste, ensuring that the system is not only effective but also intelligent.
Of course, no project of this scale comes without its challenges. One of the biggest hurdles was ensuring that the robotic arm could handle the diverse range of objects it might encounter in a real-world waste segregation scenarios. This required extensive testing and calibration within the virtual environment, where we could simulate different types of waste from paper and plastic to metals and glasses. Each type of material presents its own set of challenges, whether it's the weight, texture, or shape. By simulating these factors in Unreal Engine, we were able to optimize the arm's movements and decision-making algorithms, ensuring that it could handle anything thrown its way.
But the potential of this system goes far beyond waste segregation. The 6-degree of freedom robotic arm, combined with the power of Unreal Engine and AI, represents a new frontier in robotics. Imagine using this technology in industries like manufacturing, healthcare, or even space exploration. The ability to train AI in a virtual environment and seamlessly transition to real-world application opens up endless possibilities. The project is not just about solving a current problem, it's about paving the way for future innovations in robotics and AI.
As we bring this documentary to a close, it's clear that the fusion of robotics, AI, and virtual simulation holds immense promise. The 6-degree of freedom manipulation system developed in Unreal Engine is more than just a tool for waste segregation. It's a blueprint for the future of automation. By bridging the gap between the virtual and real worlds, we have created a system that is as adaptable as it's efficient.